Let's read this question. It says, verify that the function satisfies three hypotheses of Rolle's theorem. So, hypothesis is a mathematical word for conditions. Basically, we need to check three conditions of Rolle's theorem. The three conditions of Rolle's theorem are: number one, f is continuous on the closed interval. Here the interval is given -1, 3. Second is f is differentiable on the open interval, which is given. The third is that f of a, here a is given as -1, is equal to f of 3. Now, what kind of function is f? F is a polynomial. Polynomials are continuous everywhere, so it has to be continuous on this interval. Polynomials are differentiable everywhere, so it has to be differentiable on this interval. Lastly, we need to check f of -1. So let's just find f of -1. F of -1 is 2 times -1 square minus 4 times -1 plus 5. That would be 2 plus 4 plus 5, and that is 11. F of 3 is 2 times 3 square minus 4 times 3 plus 5. That's coming as 18 minus 12 plus 5. That's also 11. So you guys notice that these are equal. So we check the third conditions too. So first part is done. First part was to verify three hypotheses of Rolle's theorem. Then we have the conclusion of Rolle's theorem. What is the conclusion? Conclusion is, it says there is a C such that f prime C is equal to 0. So we need to find this C, find all the number C such that conclusion of Rolle's theorem. Okay, so for this, we need to first figure out what f prime C is. The function is 2x squared minus 4x plus 5. Let's find f prime, that's the derivative of this. That's going to be 4x minus 4. We want f prime c to be 0. F prime c would be 4c minus 4 equal to 0. So basically we need to solve this equation. 4c is equal to 4, c is equal to 1. You always need to check if this belongs to your given interval. So 1 does belong, so that is also true. So that is the value of C. We found it. That's a final answer for the question, which satisfies the conclusion of Rolle's theorem. Let's do the second part of the same question, Rolle's theorem. Again, we need to verify the conditions. Okay, we know the conditions now. Number one is continuity. This is a sine function. Sine function, if you notice, it is continuous wave from -infinity to infinity. So f is continuous everywhere. Clearly, it's going to be continuous on the given interval, which is this one. Also, sine is a smooth wave without any corners from -infinity to infinity. F is differentiable everywhere. Obviously, it's gonna be differentiable in the open interval pi by 2 to 3 pi by 2. The last condition is that f at the end points, it has the same value. Let's check that out. How are we gonna check that out? We're gonna find f of pi by 2 first, which is sine of pi by 2 by 2, which is gonna be sine of pi by 4. What is that? Root 2 by 2. What is f of 3 pi by 2? Which is sine of 3 pi by 2 by 2. Basically sine of 3 pi by 4, which is also root 2 by 2. You guys notice these both things are equal to each other. So all three conditions of Rolle's theorem are verified. We are good with that verification. Now let's write the conclusion. The conclusion says there exists a C such that in the interval that f prime C is equal to 0. So for that, first step would be to find f prime. F prime of x, what is the derivative of sine? Cosine x by 2 times half, because of the chain rule, derivative of x by 2. So basically half cosine x by 2. We need to find where f prime C is equal to 0. F prime C would be half cosine C by 2 equal to 0. That would imply cosine C by 2 equal to 0 because half cannot be 0, right? Where is cosine 0 in this interval? Cosine is 0 at when the angle is pi by 2 and 3 pi by 2. So C should be equal to either pi or 3 pi. 3 pi is not in this interval, so only value which is in this interval is pi. So C is pi, which belongs to the interval. Your answer should be in the given interval. Okay. So we found the C which satisfy the conclusion. You can check also. Let's try. If you find cosine pi by 2 with half, this is f prime C. That is gonna come out to be 0, right? So we found a C. This is your final answer. C is equal to pi, which belongs to the interval, such that it satisfies Rolle's theorem's conditions.